Good morning, this is Brent from SolarEdge in New South Wales and the ACT, and today we're going to do a quick presentation about how you can speed up your SolarEdge installations. There's three things that we want to address today. The first one is getting the AC connected to the inverter before you do all of the DC work. Secondly, why we think it's a great idea to test the DC before you're plugging it in to the inverter. And lastly, a quick recap on how to string your SolarEdge system for the best performance. So let's talk about connecting the AC early. Why do we think that it's a good idea to work smart and get the grid connected to the inverter before the DC? Well, there's a couple of benefits to this. Firstly, main one is once the inverter is powered up with setup, you can connect to it and you can do the following tasks in a fairly unattended fashion while you're doing other things on site. You could do the firmware update. That could take anywhere from 5 to 10 to 15 minutes, depending on the hardware you've got connected. And that means you're not confronting that issue at the end of the day, saving you time by multitasking. Second thing you can do is connect to the Wi-Fi. And that means that you've now got backup. You've got some assistance here on tap that if you have any issues in the second half of the day, support can tap into the inverter and look at it, and your office may be able to tap in onto that site and do things like helping you with layout changes or things like this as needed. The third thing that I'd recommend doing before you turn off the inverter to connect your DC is to set your grid settings. Get that ready and done while you've got the inverter turned on. It's one less thing to do later in the day, and it's just a couple of button presses on your phone. Now, as a final bonus, by doing these tasks earlier in the day, not confronting them at the end of the day, you're very likely to be pairing your optimizers maybe 15-20 minutes earlier. And that means that they're going to pair faster because more light means that the optimizers will pair quicker. Now, quick recap on grid settings. On the east coast of Australia these days, under the new standards with 4777.2/2020, we need to be setting our inverters to Australia Zone A. Don't leave it on the default Australia. That means there's no grid settings. You need to change it to Australia Zone A if you're in New South Wales and the ACT. In fact, this applies to Queensland and Victoria and other territories as well. Check what you need to be doing, but Zone A is the most common one at this point. Moving on, we've talked about getting the AC connected to the inverter. Hopefully you're convinced. Let's talk about testing your DC before you connect to the inverter. Now, why do we test before we connect? Well, it reveals a couple of different things with different tests. And firstly, it's simple that if you're confident of the roof before you're connecting it, then there's no need to stick around for pairing the optimizers. If you know that all of the DC is working as expected, why wait to watch a number creep up when you know what's going on? DC testing as you go may only add a few minutes to each string as you're doing them, whereas pairing could take 15 to 20 minutes depending on the size of the system. It's obviously faster to have your confidence built up by doing the DC testing rather than waiting for pairing to complete. And lastly, pairing can be started remotely. If you don't get time at the end of the day because you've got a big system and you're pushing yourself to get through it all, you can always pair that system later, but you won't be able to do that with confidence unless you've tested the DC as you go. And late in the day, in winter, for example, which we're now coming into as I make this recording, your east-facing panels may not even pair late in the day in winter because they may not have enough light and voltage on them. So why sit around waiting for 20 minutes to find out? When it comes to testing your strings, let's talk about the two fundamental tests that we love to see people doing when they're installing SolarEdge. First one is a voltage test. Why is a voltage test crucial? Because it confirms that your optimizers are plugged in correctly and they're functioning as expected. That's a good thing. However, a lot of guys just leave it at that. We would all love to see you doing more current testing because current testing will confirm that the connections are solid and the polarity is good all the way from the roof down to the inverter. So they're two different things. Voltage to check that your optimizers are on and working. Current testing tells you that all your connections are solid, and that is equally important. So let's recap on the figures that you would expect when you're doing voltage, current, and mega testing with SolarEdge. Firstly, let's start with the simple one, with voltage. With SolarEdge, we have our safe DC voltage there, which will be approximately 1 volt per optimizer for residential. So anywhere from 0.9 to 1.2 is acceptable depending on the panel and the light. For the purposes of training, let's just assume that it's 1 volt. So if we've got 12 panels and 12 optimizers on a string in series, what are we expecting? 12 volts. What if we're getting 50 volts when we test that string? What that is revealing is that we've bypassed an optimizer and we've connected a panel directly in series with the other optimizers, because we're getting approximately 11 volts from the optimizers and 39 volts from a panel. Need to go up and fix that roof. Another common scenario might be that you've got 12 optimizers, 12 panels, but you're only getting 11 volts. Now, that can often happen if one of the panels is not plugged in securely into the optimizer to power that optimizer. Let's move downstream now. We're using two strings here of 12 and 10, and we've connected them up on the roof with a branch connector or a Y connector before we bring them down to the built-in isolator. Now, if we're testing on that just downstream of that connection, what do we expect to see on our voltage? You're only going to see the voltage of the longest string when you're paralleling with voltage. And this is why it is so crucial to be testing as you go, because if you leave your testing until you're down on the ground, you're not going to see the results on the short strings on your roof. You're only going to see the results on the longest string. You're blind to what's going on with the optimizer connections on the shorter string of the two strings here. That's why please consider testing as you go before you combine things. Test on the roof before you plug it together and move it down to the ground. What about if we're getting 22 volts here? Pretty simple explanation is that they have been connected in series rather than in parallel. Now, here's a final hypothetical situation here. We've got 12 panels and optimizers. We're getting 11 volts, but we have done a current and a mega test, and everything checks out fine. From SolarEdge's perspective, we would say let's work smart, not hard. Since there's no fault, pair the system, get it working, and check that all the panels are reporting. If they're not, look at the serial numbers in setup to see which one is missing. Then you can know from your roof map exactly where to go on the roof and what you need to address. So that's voltage testing. Let's move on to current testing. When we're testing a SolarEdge residential optimizer, you'd expect a figure of anywhere from 250, 300 milliamps up to 600 milliamps per optimizer. For the purposes of training, we're going to say that it's 500 milliamps. And if it's a 2-for-1 commercial optimizer, that number will be slightly higher, up around 700 milliamps, but it could go all the way up to an amp or down to 400, depending on your meter accuracy and other factors. So for the purpose of this training, we're going to assume for residential, it's roughly 500 milliamps per optimizer. So we've got a string of residential optimizers here, connected them all in series, 500 milliamps a piece. What do we get on that string when we do a closed circuit, short circuit current test? We're going to get 500 milliamps because when you connect them in series, your voltage increases, but your current remains the same. Now, what if we get our voltage check here and we've got 10 volts, no problems, but when we check the current, we get nothing? What is going on? Well, what's happened here is you've got a bad connection, and what we find very commonly is this is often on the return lead. So a bad connection or an unseated connection is going to allow voltage to be measured, but it's not going to allow current to flow. And that's why it's crucial to do your current testing as you go on each string to make sure that all your connections are solid. Let's look downstream here. If we're testing at the ground, we've got two strings here, 12 and 10 optimizers a piece. We're combining those down on the ground and we're testing down at the bottom. So 500 milliamps a piece combined together when you parallel means that we're going to see roughly 1 amp there down on the ground. Now, what if we're getting nothing? We're measuring no current at all. Well, if you're measuring no current, there's a pretty good reason. It's because you've reversed the polarity on one of your strings. So you've got 500 milliamps on one and minus 500 milliamps on the other, cancelling each other out. Finally, you've checked everything, you've plugged it into the inverter and it's not pairing. What's going on here? Well, the only thing left to check is going to be the polarity at the inverter terminals. If that's reversed, again, the system will not pair. Polarity is crucial for SolarEdge to function for the communication between the inverter and the optimizers. Final check to talk about is mega testing using your insulation resistance testing. So with SolarEdge optimizers, to test that string, it should be a shorted test at 500 volts from a common joint to earth, and you're testing across your string to earth. Now, a common value there would be somewhere up around 100 mega ohms. And the main point of this is to compare your strings and make sure that they're the same. So if you've got a string which is measuring really well up around 100 mega ohms, but I've got another one which is measuring 10, you must have an issue there. So check for pinched cables, check for bad connections. There's somewhere you've got an earth leak, which is going to be an isolation issue for you. So definitely check that before leaving site. Final topic for today is a quick recap on how to improve the performance of your SolarEdge system. Power optimizers will always work best when they're not pushed to their limits. And that happens when you have a short string. Long strings are always more capable of dealing with shade and mismatch than short strings, because you've got more optimizers to contribute to the 380 to 400 volts fixed on that string. High voltage optimizers like P505s are more capable of dealing with shade than low voltage optimizers like S440s and P401s, because they have 80 volts of boost, whereas a P401 or an S440 only has 60 volts of boost. And lastly, remember that the string current is under the control of the inverter. SolarEdge is unique. We are the only solar system in the world, to my knowledge, where we can control the roof from the ground. We control that DC, and our lever to do that is the current. So the string current is under the control of the inverter. The maximum current on the roof will be dictated by the maximum input current on the inverter that you're using. Now, when it comes to design, long strings are good. We love long strings because they improve performance. But you need to design how you're going to work them, say if you've got 3 orientations. So what we'd suggest is stringing your system as the sun moves. So for example, on 3 orientations, if you want to do 2 long strings, go from east around to north, combine those together so that you've now got 1 long morning string. You then continue from north around to west on your second string. You've got a tracker on every panel. You've got that design flexibility to do that. That's going to improve your performance because you're maximizing the number of optimizers in light on each of those 2 strings. The thing to avoid is just leaving all the north on one string and combining east and west on the other. Because if you do that, east and west are going to fire at different times of day. They're not going to help each other to reach your fixed string voltage. So you will get, lulled into a false sense of security. So where possible, try to combine east and north, north with west. Split north and you'll improve the performance of your system rather than combining east and west unless you've got high output optimizers or a really long string. Quick recap on screen here of our string lengths. Main thing to notice at the top on our single phase versus our 3-phase. On all 5 and 10 kilowatt inverters, single and 3-phase, we can go up to 6,666 watts on a string, no problems. But the numbers on the ones in the middle, on the 6 and the 8.25, and the 7 and the 8.25 in the 3-phase range is slightly different. So be aware of those differences in your maximum string lengths. Some guys get confused when they see on the data sheet that you're allowed to have up to 25 optimizers, but the thing is, it's 25 optimizers or the string limit, whichever is less. Now, given the wattage of panels these days, this is the crucial limit, not the optimizer limit. That's to do with communication. So these are our string limits that matter. Make sure that you've got them on hand somewhere when you're working with our products. Final tip that I would love to share with everybody is to consider our training and certification systems, because we have a lot of great material available on Edge Academy on the SolarEdge website. The first course we have is SolarEdge Installations Essentials. You get 30 CPD points for completing this one, and it covers all the fundamentals of working with SolarEdge. Wouldn't take you more than an hour to an hour and a half to complete that one. So fantastic course to consider. That is a prerequisite then to do our SolarEdge home battery certification, which we want to see everybody complete if they're doing our batteries. In the home battery course, you can brush up on batteries. It goes through the tech webinar, goes through the unpacking, mounting, the floor mount, the wiring, commissioning, and uninstalling process, as well as having a certification exam in there. So all of those resources are available online for free 24/7. Please consider giving those a go. Thanks very much for everyone's attention. This is Brent from SolarEdge in New South Wales and the ACT. All the best.